a random variable is a measurable function x from S to R. So, here one example it is given for a random experiment of tossing a coin. The sample space is S is equal to head and tail. So, we may define the random variable as x of head is equal to 1 and x of tail is equal to 0. So, then this we have shown that it is a measurable function and it is a random variable. So, there are many example you can we can show that this is not a something. So, something not a random variable. For example, if you consider instead of this collection, if you consider suppose sample space is head and tail, or let us consider another random variable. Let us another random experiment let us consider. Suppose rolling a die. So, then our sample space S2, suppose S2 we are denoting by 1, 2, 3, 4, 5 and 6. So, let us consider only this. Suppose C2 is nothing but, okay, C2 we have already denoted. So, let us consider F2. F2 is nothing but just phi and S2. So, this is a sigma field because if you consider if you take the union and complements, all will be inside this set. Now, we want to define a random variable. Suppose x2 is another random variable S2 to R. So, then we want to define this random variable. So, because it is S2, so x2 of S is equal to 1 if S belongs to, it is a even number 2, 4, 6, and this is equal to 0 if S belongs to 1, 3, 5. Okay. Now, suppose we want to get the okay. Now, I think yeah. Now, if it is a it is a measurable function, then we have to consider suppose what is the suppose B is one Borel set minus infinity to suppose one Borel set we consider. So, then what is x2 inverse of B? So, x2 inverse of B is nothing but, so x2 inverse of B how we will compute? So, all the element in this S2 satisfying this relationship x2 of S is less than equal to 1 and this is greater than minus infinity. So, what are those values that it is satisfying this? Because this is okay, I have taken x2 okay, yeah. So, then this is satisfying by all the element. So, it is all the element because 1 or 0. So, that is why no problem, it is satisfying by all the element. So, that is why this set will be all the S2, all S2, and S2 is belongs to F2, no problem. Now, if you consider this set, this is 0, B is nothing but minus infinity to 0. So, then this will be nothing but all S satisfying x2 S is less than equal to 0 greater than minus infinity. So, what are those elements satisfying this relation? Because x2 is equal to 0 whenever it is those values. So, this is nothing but 1, 3 and 5. Whether 1, 3, 5 in F2, it does not, it is not F2 because F2 contain only phi and S2 and it is the sigma field we are considering. So, it does not belongs to F2. So, x2 is not a measurable function. Hence x2 is not a random variable. So, x2 is not a random variable. So, now basically now I hope you have now understood that the concept of random variable, that it has to be a measurable function from the sample space S to sample space S to Borel sigma field R. So, that it has to be Borel measurable. Now, we say Borel measurable because we are considering the R and the Borel sigma field, and we are considering this measurable function with respect to the Borel sigma field. Now, there are some of the other numerical example, let us discuss. So, I hope you have understood that events defined by the random variable. So, it is nothing but what is defined by, this is this thing, x is equal to x. So, I just take this notation s such that x of s is equal to x, and what is kind of notation, this notation. So, all kind of things we can have. So, suppose let us denote another. So, for this example, so it is not a, so now this example you can see that x less than equal to 1. Also we can define this function also here, x1 is less than equal to x2. So, let us do one numerical example. So, another numerical. So, here one numerical examples are given. So, in the experiment of tossing a fair coin 3 times, the sample space S1 consists of 8 equally likely sample points. S1 is equal to like this. So, basically a fair coin means whenever we say a coin is fair, or we say sometimes that the coin is unbiased. So, that means both head and tail are equally likely, head and tail, and that means probability of head is half, we will consider that. And 3 times we are tossing a coin, then if you toss the coin 3 times, then what will be your output, possible output? Suppose you are tossing once, then it will be head and tail, second time it may be again head and tail, and third time it will be again a head and tail. So, your output once you are repeat just one trial, your output it will be looks like maybe head, then head and head. So, that is why this sample space here S1 it is written. So, this notation we will consider. So, it may be head, or it may be first time head, second time also head, third time again it is tail. It may be first time head, second time tail, then third time head, tail, tail, head, head, tail, head, tail, then tail, head, tail, head, tail. So, tail, head, then tail, tail. So, how many? 1, 2, 3, 4, 5, 6, 7. So, head, tail, head, tail. So, tail, head, then tail, head, tail, then tail, head also there. Sorry. So, there will be some other observation, tail, head, tail also there, tail, head, tail, 1 minute, tail, head, tail already we have done written, tail, head, tail, head is there, and then tail. So, there will be 8 observations, 1, 2, 3, 4, 5, 6, 7, 8. So, there will be 8 samples points for this random experiment. So, now it is written here, if x is the random variable giving the number of heads obtained. So, basically whenever this observation coming, so then what is the number of heads? So, number of heads is 3. So, if this is coming, so number of heads is 2. So, similarly you can think that, so if this observation we see, so number of head will be 0. So, then this random variable is defined, x is the random variable, it is defined as the number of head obtained. So, any point S belongs to S1, x of S is nothing but number of heads obtained. So, now so how it is defined? So, basically this is the sample space S we denoted. So, how x head, because it is, so for this case this x will be 3. So, x of head, it will be number of head will be nothing but 3. Similarly, for this case, suppose x of head, tail. So, what will be number of head? So, number of head will be 2. So, similarly, you can see for this case also 2, for this case also 2, for this case number of head is 1, for this case number of head will be 2, this case number of head will be 1, this case number of head will be 1, and this case just I am writing x of tail, this is nothing but 0. Now, this is the random variable, it is defined. So, it can be easily shown that you can see that it is a measurable function, it will be a measurable function, you can check it, and we have already discussed what is measurable function, how to check all these things. Now, by measurable function we can have we can define the event. So, event means that it is a what is event? Event means it is a subset of the sample space that belongs to that sigma field. So, that means x is a measurable function. So, x inverse. So, because just we want to mention again these things. So, x minus x inverse of any Borel set, it is belongs to C. So, it is belongs to C means it is a event. So, it is a event means it is a subset of S that belongs to the sigma field. So, this is phi belongs to C, that is a. So, that is why by this way we can define the so x less than equal to 1, it is nothing but the subset of S that belongs to C. So, it is a event. Event means nothing but it is a subset of S that belongs to the sigma field C. So, it is also a event. Now, whenever it is a event, we defined the probability of a event. So, we can talk about the probability of this set. So, that means we can talk about probability of x equal to 1, probability of x less than equal to 1. So, in general probability of x less than equal to x we can talk about. So, that is the because it is a event. So, here it is asked that if x is the random variable giving the number of heads obtained, find this probability x equal to 2, x less than equal to less than 2. First we have to understand what does it mean x is equal to 2 and what is x less than 2, that we have to understand. So, then we can compute this. So, we know this notation we have already discussed, again we will do. So, what is x equal to 2? Suppose we are doing here x is equal to 2 first bracket. So, it is nothing but all S belongs to the sample space S1, this sample space S1 satisfying this relationship x of S is equal to 2. So, now we know all the value. So, what are the points satisfying x is equal to 2? So, you can see that whenever it is the number of head actually is 2. So, here you can see that HHT is there, HHT, it is number of head 2. Then HTH is also there, HTH, and also number of head 2 because it is equal to 2, exactly equal to 2, and also TH is also there, TH number of head 2, because all those points only x is equal to 2. So, and anything else, so anything else if you consider HHH, this is nothing but 3 head, that is why it will be x of head is equal to 3. So, it will not satisfy this relationship. So, for any other case also head tail only one head, T head tail this is also only one head, TT head it is all TTT it is 0. So, that is why only 3, because it is a fair coin. So, all the 8 points will be equally likely. So, if it is not a fair coin, then it may not be equally likely, because if it is more likely head, then this will be more probable than the more all this more tail where it is more tail. So, that is why it is a fair coin. So, all the elements in S1 these are equally likely. So, then what will be the probability x is equal to 2? The probability that x is equal to 2, this is nothing but because by classical approach all are equally likely, by the assumption the possible way it can come 8, total 8 possible way, and the x equal to 2 it can come the possible way 3. So, that is why it is nothing but 3 by 8. So, that is why this is actually it is explained here. You can see that let A be a subset of S1 event by x equal to 2, and we can see that x equal to 2 is nothing but these things we have already computed. Since these sample points are equally likely, we have x equal to 2 is nothing but 3 by 8. Now, another set we want to take, b is equal to x less than 2. Suppose b is equal to x less than 2. So, it is a subset of S actually, it is belongs to the sigma algebra, sorry, yeah, sigma field. So, so that is why, so this belongs to this will be a subset of S1 actually, this is subset of S1. So, how we will define this? So, we know the definition of x less than 2, how it can be defined. So, it is defined. So, this is nothing but, similarly we have already done it, x less than 2 means all x, all S belongs to S1 satisfying the relationship, this random variable x of S is less than 2. So, all S belongs to S1 satisfying the relationship that x of S is less than 2. So, then what are the point in S1 which is satisfying this relationship? So, you can see that less than 2 means, see here equal to 2 means exactly 2 we have to see, but here less than 2 means it may be 1, it may be, because what are the points it is taking 0, 1, 2 and 3, and that is known as the range of the random variable. So, because random variable is a function, so random variable function S1 to R, so range of x is nothing but the all the range of this function. So, range of x which is denoted by Rx. So, all value it is taking. So, what is the value, what are the values it is taking? Because it is taking 0, 1, 2 and 3, this is the range of x. So, range of a function we know that. So, what are those values it is taking? So, that is the range of this function, it is nothing but the range of this random variable. So, now because SS is we want to find all S belongs to S1 such that x of S is less than 2. So, that means what are the values it can do less than 2, because less than 2 means 0 and 1 it can take. So, what are the corresponding to 0? 0 is nothing but t, it is taking x of S is equal to 0, only one value it is taking 0, and 1 also we can consider, number of head is 1. So, it is nothing but TTH, only one head, and then THT also, and then HTT also, HTT. So, THT, HTT, and any other point you can see that number of head will be more than 1. So, that is why this is 4, because it is 4 elements, and because it is equally likely, all our points are equally likely, probability of B is nothing but, this is nothing but probability of x less than 2, which is nothing but, because total possible way it can appear, and the possible way that the event B, that means x less than 2 can happen. So, that is nothing but total 4 by classical approach, 4 by 8, this is nothing but the probability is 1 by 2. So, here also it is represented B subset of S1, the event defined by x less than 2, then B is nothing but x less than 2. So, this is nothing but these values. So, we have already discussed it, and then probability that x less than 2, the probability of B 4 by 8, which is nothing but 1 by 2. So, this is one example we discussed how random variable it is a measurable function, and how this random variable can be used for defining the events, and then we can found by the random variable, using the random variable we can find the probability. What is the probability we can find it. So, now next we will discuss the distribution function. Now, we will learn what is distribution function associated with a random variable. So, we recall that if we consider a random experiment. So, let us repeat this same example to understand it clearly. Suppose you are doing this random experiment, tossing a coin. So, then what is the sample space? Sample space is head and tail. Now, if we consider the sigma field as the power set of S, we already discussed what is power set. It contains all the subset of S. So, suppose C is the power set. So, it is H, T and also S and phi containing all the subset of S. So, now we define a random variable. So, random variable x is nothing but S to R, it is a measurable function. So, we can define any random variable, but let us consider this standard random variable x of head equal to 1 and x of tail is equal to 0. So, we are relating this abstract space to a real number, set of real number by this notation, and we can also go back to this space by this random variable. So, if you consider this set x less than equal to x, what is this? So, x is any real number, x is any real number. If you consider this set x is less than equal to x, this is nothing but all S belongs to the sample space S satisfying x of S less than equal to x, and obviously because the left hand side we do not write, then we understand that it is greater than minus infinity, because x is mapping from S to R. Now, if you x is any real number, now for different values of x, let us see what are this set. So, this set, this will be a subset of S and it is a measurable function, so it belongs to C. Now, if you consider x is suppose some negative number minus 1.5 something, some number, then x less than equal to minus 1.5, what is this set? So, this set is equal to S such that minus infinity to less than x of S less than equal to x is minus 1.5. So, this is minus 1.5. So, now x of S satisfying the relation, what are the S it is satisfying, because x of head is 1, x of tail is 0, none of these values satisfying this relationship. So, this is nothing but the null set. So, basically it is a subset of S. Now, if you consider x is some other value, suppose x is 0 suppose, then you can easily show that x less than equal to 0. I hope you have understood now very clearly. Just you have to find this value x of S less than equal to 0. So, what are those S satisfying this relationship x s is less than equal to 0. So, this is nothing but because x of tail is only 0. So, this is nothing but t. Now, if you consider x is equal to 1, so then x less than equal to 1, all S satisfying this S belongs to S such that minus into x s less than equal to 1. So, then this is nothing but all the S satisfying this, because x of head is equal to 1 and x of tail is equal to 0. So, that is why these all satisfying this. So, this is nothing but tail and head, this is nothing but S. So, all are subset of S and also belongs to C, C is power set. So, in this way, by taking complement of that, so or any union operation, complement operation, all these things, you can show that all by this set you can have all the, if you consider for all x belongs to real number, you know this set, then you know all the subset of S. So, if you can find the probability of these things, so then you can, because these are all events. So, it is a subset of S means these are all events. So, if you know the probability of this kind of set, that means events, then you know, if we know, then we know probability of any event associated to the random phenomena. So that is why if you know this value, you know any probability associated with the random phenomena. So that is why knowing this, if we know these things, it is very important. So if you know this, we know probability of any events associated with the random phenomena. So we want to define as a function, because it is nothing but it is a kind of a function of, because any x you give, you giving some value, we define a function here. So this function is denoted by, for x is a random variable, let x be a random variable. So usually we do not say always the x is a function from S to R, we just for a simplicity we just say x be a random variable. That means it is a function from S to R. Not only that, it is a measurable function and it is the sample space associated with the random phenomena. So x be a random variable, a distribution function f. So we denoted by f of x. So it is distribution function. This distribution function is nothing but, or this will be for any real number it is taking, and it is actually inside 0 to 1 actually. A distribution function is defined by f of x of any real number x, nothing but probability that x less than equal to x. So sometimes this is also known as cumulative. So we say it is cumulative distribution function, cumulative distribution function. So this is nothing but CDF. We sometimes say CDF. Cumulative, why? Because we are considering the probability that all random variable taking the values less than equal to x. So that means for any real number x here, you want to know the probability that x is belongs to this interval minus infinity to x. So that is why cumulative, it is not a particular point, just it is minus infinity to x up to x, it is just you are taking the probability that x is less than. So this is the for all any x, for all x belongs to real number. So if you know this function is CDF, then you know this probability, and then you know the probability of any event associated with this random experiment or random phenomenon. So this is the distribution function. So now let us discuss one example. So this is distribution function or cumulative distribution function. It is SBA sample space of a random experiment E, and x S to R be a random variable. The distribution function is a function, or cumulative distribution function is a function f R to 0 1 defined by f of x is equal to nothing but probability that x is less than equal to x for any real number x. So let us denote one, let us discuss one example. So then we will discuss some properties. So okay, where is this example? Okay, I think somewhere. Okay. So let us consider this example, tossing a coin 3 times. So then we will find the cumulative distribution function. So let us consider the random experiment. Tossing a coin. So whenever we do not mention coin is biased or what is the probability of head, then we assume that this is a unbiased coin or it is a fair coin. So whenever you are tossing a coin 3 times, we just discussed that this sample space S1 contains 8 elements. So, this is nothing but head, tail, sorry, head and head, tail, then head, tail, sorry. Then tail, head, tail, 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 head, tail, tail. So, this is the 8 elements it contains, and we define the random variable x is that x is defined by number of heads obtained. So, basically we found already x of head is nothing but 3, x of head tail is nothing but 2, like this, x of suppose tail head is nothing but 1, x of tail is nothing but 0. So, range of x is nothing but range of x, that means range of this function x is nothing but 0, 1, 2 and 3. These are the 4 values it is taking. Now, we want to define, we want to find the CDF, cumulative distribution function associated with this random variable x. So, what is the definition of cumulative distribution function? This is nothing but f of x, this is nothing but defined by probability that x is less than equal to x for any real number, for all real number x belongs to R. So, now basically this function you have to give for any real number. So, note that we have to find for any x belongs to real number, we have to find the probability of these things. Let us find out this value of this function for some of the particular values of this real number x. Suppose x is some value, suppose let us take, because okay, let us take some negative number 2.5. So, then what will be the fx of 2.5 minus 2.5? This is nothing but probability that x less than equal to minus 2.5. Now, whenever you want to find this value x is less than equal to minus 2.5, first you have to find what is this. This is a event, it is a corresponds to this random variable, we have to find the event. So, what is this event? X less than equal to minus 2.5. So, this is nothing but defined by all s belongs to the set S1 such that x of s less than equal to minus 2.5. So, then see that x take the value 0, 1, 2, only positive value it is taking. So, less than equal to minus 2.5 it is not, any value in s equal to S1 can be satisfied. So, it is nothing but the null set. So, that is why probability of x less than equal to minus 2.5 is nothing but probability of phi, this is equal to 0. So, for any real number x which is negative, you can see that this will be null set, because any real number if you negative number you take, then this set will be, because x is always taking the positive numbers. So, for any small x is less than, so if x is less than 0, then x less than equal to x, this will be nothing but the null set, x is less than 0. So, whenever x is less than 0, any number like minus 2.5, any number, then if you can find this set, so any number, so it will be less than this negative number, so that is null set. So, probability will be 0. So, that is why what we found that for this distribution function, for this example, f of x, that is nothing but probability of x less than equal to x, this is nothing but 0 if x is less than 0, greater than minus infinity. Note that this we are not finding the probability of this interval, we are taking one value from here and we are putting this value here, and then we are finding probability of this interval, and we saw that if this number is any value in this interval, then this probability of these things will be equal to 0. Now, let us consider, because it is negative number, let us consider small x is exactly equal to 0. So, it is a real number, small x is exactly equal to 0. So, then what will be this set, because we want to find probability of x less than equal to 0. So then x less than equal to 0, what is this set? This set is nothing but S belongs to S1 such that x of S is less than equal to 0. And sometimes we do not write it because for simplicity we understand that left hand side nothing we are writing means this is minus greater than minus infinity. Now note that this here this is taking 0, 1, 2, 3 and for this t only this is equal to 0, otherwise it is greater than 0. So it is less than equal to 0, so equal to 0 only it is satisfying by this t. So hence by classical approach, because it is a fair coin, so equally like, so x less than equal to 0, this is nothing but probability of x less than equal to 0, nothing but probability that this event contain only one point. So and out of possible 8 point, only one possible whether it can come, that is why it is 1 by 8. Now if you take any value, so suppose x is greater than 0 but less than 1, suppose x is any value, suppose x is equal to 0.8 suppose. So then what will be the this set, because you want to find the probability of these things. So first you have to find x is less than equal to 0.8, this probability you want to find, probability of this event. So this is nothing but S belongs to S1 such that minus magnitude to greater than xs less than equal to 0.8. Here also you can see that because we are not finding the probability of, we want to find the probability that xs is, so here small x is 0.8. So any value we are considering here belongs to greater than equal to 0 less than 1. So for example x is equal to 0 we consider, x is equal to 0.8. So here we are not finding probability that x equal to 0.8, we are finding capital X less than equal to 0.8. So that we have to be careful. So then this set, what is this set? See that this random variable x can take this value only 0, 1, 2, 3 and because only for s it is less than equal to 0.8 is nothing but only t again, only because it is 0, otherwise for other value it is 1. So that is why again probability that x less than equal to 0.8 is nothing but again 1.8. So for any small x between 0 greater than equal to 0, for any small x greater than equal to 0 and less than 1, in that case probability that x less than equal to x, so this is the distribution function, probability that f of x, this is probability that x is less than equal to small x, greater than minus infinity we sometimes write minus. So this is the fxx definition. Whenever x is between this, then probability is becoming 1 by 8. So note that here question is that sometimes it is confusing, we are finding x greater than equal to 0 less than 1, it is not true, it is not correct. So basically we are taking the small x, actually the small x is between 0 to 1 and this small x we are putting here, x is less than equal to small x, that is why x is less than equal to small x. So x is any value you consider here between 0 to 1, then this probability f of x, this function we are finding, this function is nothing but 1 by 8.